All right, how you doing? Wish I was here today, but I'm not, so I wanted to go ahead and go over some notes with you in my absence. So I'm in your notes packet, right? Make sure you're in the notes packet. Okay, and I'm on page 8. We are in section 4.3. We're going to work a little bit exclusively with isosceles and equilateral triangles. So I want to make sure that those words mean something to you. So for a second right now, make sure you can list out what an isosceles triangle has. How do we know something is an isosceles triangle? Think to yourself. Okay. You should have thought that two sides were congruent. Okay. And what about an equilateral triangle? What do you know about that? That's a specialist of them all, right? This has three sides congruent, right? And of course, because of that, we have three angles that are also congruent. Okay, so we're going to be talking about those exclusively. The first example here is with these isosceles triangle here, okay, in the picture. So it says our goal, we're going to use these properties to kind of solve for some variables, okay, and make some assumptions about a diagram. So we're going to have this isosceles triangle that we're working with here, okay, and we have a base angles theorem. It says if two sides of a triangle are congruent. So can we mark the two sides in this triangle that are congruent? This guy and this guy, right? It says then the angles opposite them are congruent. Okay, so the other day we learned about how to talk. Let's call this A, angle A, angle B, and angle C. We learned that the angle that's opposite AC, right, must be angle B. And the angle that's opposite AB must be this angle over here, angle C. So kind of like I always think of it, if you follow down the two sides that are congruent, those two angles that your fingers come to, those two angles are congruent. Okay? Okay? And then we have a converse to that, which is kind of just saying the opposite. This says if two base angles are congruent, then the sides opposite them are congruent too. Okay, so it's just kind of saying the reverse. Okay, I'll give you a second to write that down. Okay. And then I kind of want to orient a triangle for you a little bit different than the way this looks. You know, you can pause it if you didn't get that all written down yet and finish writing and then come back. Okay, so basically it works both ways. If the two sides are congruent, you know the two base angles are congruent, and this converse says just the other way around. If you know two base angles are congruent, then you know the sides are. So I want to draw a little picture for you that kind of has the triangle being oriented a little bit differently. So I'm going to try to draw two sides that are the same length. Okay, those look to be roughly the same length. Okay, so it's facing a little bit different. And I'm going to go ahead and mark these two base angles. So base angles, right, doesn't always mean that they have to be on the bottom. In this drawing, let's call this triangle DEF, right? These are my base angles. And since the base angles here are congruent, I know that these two sides here are congruent. So I've just kind of marked it in the reverse order than I did up above here, okay? And so the way that we could write this out, we could say, if angle E is congruent to angle F, then we know that side DE is congruent to side DF. Okay? Just following up to the two congruent sides of the triangle. Okay? Okay, let's go ahead and flip it over. We're on to page 9, almost done. We're going to go ahead and do a problem that utilizes that information in the theorems that we just did. Now, this is supposed to be a 5, and this is supposed to be an X. I'm not sure how good it copied on your page, okay? But the first thing I have to kind of take note in this drawing, right, is that I have two angles that are marked congruent. So this must be an isosceles triangle. Since it's an isosceles triangle, right, I know that it's two sides here and here are congruent, okay? Remember, base angles aren't always at the bottom. It depends on the way that the triangle is sitting. So since I have this side congruent to that side, right, they are opposite the base angles, right? I know that X, the length of this side, must also be 6, okay? Because I use that relationship, okay? All right, let's go down. I'm going to kind of hop around here a little bit. I'm going to go down to example 3 now, because it's kind of utilizing that isosceles information again, okay? Now this one's fully marked for us. I kind of dig it, right? We've got two congruent angles, therefore we have two congruent sides, okay? and I know that the vertex angle here of this isosceles is 70 degrees, and then I know one of the base angles is called x. My job is to find the value of x. Well, I know if this guy is x degrees, I know that guy is x degrees, right? So there's two ways you can do this. I know that the three angles in a triangle add up to 180 degrees, so you could do 70 plus x equals 180, right? That looks pretty cool, right? And then I can simplify this. 70 plus 2x equals 180. I can subtract 70. I'll have 110 remaining, and then I can divide by 2. X is 55. Cool. Okay, that's one way of doing it. The other way of doing it here is by thinking about, okay, I know that there's 188 degrees total in this triangle, and I know that 70 of it is taken up, right, by this vertex angle. So in my head, I can do that subtraction, just because this number is easy to subtract from 180, and I get 110. Right? So a second way to do this might be to take the 110 degrees that's left over and know that you have to split it equally between the two x's, right? And so 110 has to be divided in half to get that same answer of 55. So you can choose whichever method makes sense to you. Okay? I like either method just the same, as long as we all get the same answer. Okay? I've got another example I want you to add in down here. So let's kind of section off some space. I'm going to give you just a rough diagram, okay, and some measures. So I'm going to make my isosceles triangle look like this time. Okay, and this is all I'm going to give you. I'm going to call this guy Y. I'm going to say this guy in here is 40, and I'm going to call this guy over here X. Okay. So now, looking at this example, I want you to find both x and y. Let me make that a little bit bigger so you can see it. Okay. And I want you to go a little bit slower with this one, right? Because this isosceles triangle is kind of oriented a little bit different, right? So which of the two angles are you going to find first, x or y? Okay. For me, I'm going to go ahead and find x first, because I notice that these two are the congruent sides. So if I follow down to the ends of them over here, these must be my congruent base angles, right? And so I know that x must be 40 degrees. I have to do a little bit of calculation to get the y, right? So I have 40 and 40 for my two base angles. If I add that to y, right, I would get 180 degrees total in that triangle, right? So I'm going to go ahead and simplify this. 80 plus y equals 180. And I'm going to end up with y equal to 100 after I subtract 80 from both sides. So those are my two answers. Okay. All right, now we can go up here. These examples here kind of go together right in the middle of the page. So if you go up just under the diagram from up here, I kind of sectioned off this piece right here. This information goes along with this diagram. Okay. All right, so it says, what we know about equilateral triangles, right, is that they are also equiangular. Okay, that means that all angles are 60 degrees, right, because there's three of them and they have to add up to 180. And then we also know that an equiangular triangle is always equilateral. Okay, I know that sounds silly, like we're just saying the same thing over and over again. But we really do need to kind of concentrate on that relationship between equiangular and equilateral and what it means in terms of the problems that we do. Okay, so in this picture here, we're supposed to find the value of x. And the only way to figure this out, since I don't have any other measures here, is to kind of take these markings into account, right? So I know from these markings that this is an equilateral triangle. And if it's equilateral, I just got reminded up here, right, that it must be equiangular. Okay, so that means that my x, right, simply taking 180 degrees, dividing it by 3, must be 60 degrees. Any time for the rest of your life and the rest of this class, you encounter an equilateral triangle, you're always going to have a 60-degree measure for every single angle. Okay, that's kind of how that works out. Okay, all right, that's all for the notes today. Make sure you get all of that copied down. And you can hit stop.